Thank you for watching this video on how to measure the AM to AM of an RF link, or in other words, measure the output power versus the input power of a particular RF link. In this case, our link here consists of several components. The first component being a stimulus or a CW signal, followed by a filter, an amplifier model. The amplifier model is followed by a filter to reject the noise at the image frequency. We have an isolator, a converter or a mixer, and the last model here is a low-pass filter terminated into a 50 ohm load. I'll run the simulation here to analyze the gain of the RF link as well as the noise figure. The gain of this link is almost about 4 dB. The noise figure in this link is about 3.6 dB. The goal over here is to create a graph where we can get an indication of power out versus PN. So to do that, we have to introduce a swept variable. To introduce a swept variable in a system diagram, we'll go to the Elements browser, Simulation Control node, pull out the swept variable block, and we'll use this block to define the variable and the step size or the power sweep that we want the RF link to use. So the variable will be called power. We'll use the stepped function to indicate to VSS that we want to start at a power level of minus 12 dBm, go to 10 dBm, in steps of 2 dBm. So note here the method of doing this. You write stepped, open parenthesis, minus 12, comma, that's the start, minus 12, the end is 10, and the step is 2, and there's a comma in between the 10 and the 2. So here we'll accept this for the swept variable. Note here in the tone source or the stimulus of our system, I have initialized the variable previously to power equals minus 10. The variable is used here. It's power minus 30. Note the units are dB watts. So the minus 30 ensures that in fact we're registering dBm. The next thing we're going to do is add a graph. We'll label this graph power out versus power in. And to this graph, we'll add an RF budget measurement. Specifically, we'll select the measurement type, RF budget analysis. We'll use the measurement node power, or P underscore node. We'll indicate where we want to start the measurement at TP start 1, and where we want to end the measurement, which is TP stop 1. We'll check the radio button magnitude and check the button here or the box for dBm. Now I'll run the simulation and we'll see the resulting curve for power out versus power in, and we can see where the complete RF link goes into compression. You can take this example one step further and add AM to PM curve. To do that, you'd select RF budget analysis, cascaded underscore S21, uncheck the radio button magnitude, or I should say check the radio button angle, uncheck dB, and then perform the simulation. In this particular case of this RF link, there really is no AM to PM information on the account that these amplifier models only account for AM to AM characteristics. If you did have a model that had AM to PM information, that will be reflected in the link as well. In this current link, the only thing that will change the phase of our stimulus will be the filters. Once again, thank you for watching this video. If you have further questions about VSS, please visit our website and or read the VSS modeling guide.